Right, question 9 then. 9a, we've got to integrate by parts. So integration by parts I'll write down fully. uv dash dx equals uv minus the integral of vu dash dx. So we then put in what we've got. So u then is can be x or can be ln x, and our v dash then can be one or the other. We decide which way we're going to go around with that. Now, because the u needs differentiating and v dash needs integrating, personally I prefer to differentiate the ln x. I find that easier. So I'm going to put u equal to ln x and then v dash equal to x. So I'm differentiating that, becomes 1 over x. Integrating this becomes x squared over 2. We then put that into the integral, so we've then, what we're actually trying to find here, x ln x dx is the same as saying uv, so it's x squared ln x over 2 minus, and then we've got v, which is x squared over 2 again. This time it's the integral of it, so it's 1 over x dx. Sorry, I was interrupted there. So we've then got this bit already sorted. Now we're going to integrate this. This will cancel, so we can actually take the half outside. That'll cancel. We're just left with the integral of x. So then gives us x squared over 2 ln x minus then x squared over 2 times by a half, which means getting then x squared over 4, and then we can put a plus c at the end as well, the old arbitrary constant. So that's part A done. Part B, given that y equals ln x all squared, find dy dx. So part B, I think to me, to make this easy, or easier, I'm going to let u equal ln x. So du dx then is 1 over x. I've then got y equals u squared. So dy du equals 2u times these two together, which will then give me dy dx. So the 2u on the top, so it's 2 ln x over x. Now part C, the biggie, the 6 marker. What have we got to do with this? Diagram shows a curve, so we've got y equals root x ln x. Shaded regions bound by the curve of this, the line x equals e and x equals 1. The volume is generated by rotation to the x-axis. Right, so what we've then got is volume revolution through the x-axis. So it's pi and then x squared. So all this squared dx. Well, the pi can come on the outside, so we're then integrating x ln x squared dx. So we've then got an integration by parts to do. So the integration by parts we've got is x ln x all squared. Now we've already differentiated ln x all squared, so it'd be a good idea. We've got u to equal and we've got v dash to equal. We already know how to differentiate this, so we're going to put this down as our u, and then our v dash is x. So differentiating that, we've already done that, which is 2 ln x over x. If we integrate this then, that's x squared over 2. At that point then, what do we do next? Well, we've got to look at it and realise that we're integrating by parts. So we've done the hard work here. So the integral then of x ln x all squared dx is equal to uv, so these two, so it's x squared ln x all squared over 2, and we're also subbing it, and we've also got a pi here, haven't we, as well, just to complicate things. So I'm not going to bother with the pi in the substitution of the numbers quite yet. I'll put them back in here though, because I should have had them in here. So that's en1, so en1, en1. So the first thing I'm actually going to do is ignore the e to the 1 bits here and just get the integral out first of all. So we've got uv, which I've just said, so it's that times that, then minus v again, which is x squared over 2, but this time we're using u dash, which is 2 ln x over 2, over x, sorry. That then gives us x squared ln x all squared over 2. Here then the 2's cancel, this x cancels with this x, so we're then left with the integral of x ln x so we're then going to integrate this, so that then gives us x squared ln x all squared over 2. Now how do we integrate this? What are we going to do to integrate x ln x? Again, we've got two, we could do it by parts again. So with this time we could say we've got u equals ln x and v dash equaling x. So u dash equals 1 over x and v is equal to x squared over 2. So we're then minusing in a bracket uv, so it's that times that, so x squared over 2 ln x minus the integral there of v, which is x squared over 2, and then u dash, which is 1 over x, and eventually we'll get there. That then gives us, I'm just going to remove this bit so it stays on the page, x squared ln x squared over 2 minus x squared ln x over 2. This bit then, the x will cancel with this, leaving us with minus then, but then it's a minus of a minus, so it'll be a plus a half here, so I've cancelled this bit, so the half on the outside of the integral of just x dx. That will then give us x squared ln x all squared, all squared all over 2 minus x squared ln x over 2 plus x squared over 4. At that point you're then going to sub in your values of e and 1. So the first thing I'm going to do here is highlight this, copy this onto the next page, obviously you want me to copy all this rubbish and do this like I have. So now what we're going to do is, with this integral, we have got pi on the outside, don't forget your pi, e to the 1, and it's then we're integrating, going back right to the start now, x of this, so then it's these values here, x squared ln x all squared all 2 minus x squared ln x over 2 plus x squared over 4, subbing in e and 1. So we then get e squared, e ln e is just 1, so you just get the 1 there, all squared over 2. E squared again, that's just 1, over 2, and then e squared again over 4, and then we're taking away, subbing 1 into this, so we end up with ln 1 over 2 minus ln 1 over 2 plus 1/4. Well, the ln 1 over 2 and the ln 1 over 2 cancel. So we've then got e squared over 2 minus e squared over 2. So we then get e squared over 4 minus 1/4. I forgot my pi. My pi needs to stay in there. So times this all through by pi. So pi's there. And we can take the quarter out if we like. That gives us e squared then minus 1. Then you take a deep breath and you got it right.